I would first like to express my thankfulness to ILSI Global and particularly Dr. Stephen for giving me this opportunity. So I have been given back 10 minutes time, so maybe I will be quick. The topic is, okay. See, I belong to Indian Institute of Technology, Kharagpur. Okay, our institute to the eastern part of the country. Okay. Now, nutrition and health, they are interrelated. Okay. It is required for proper growth and development. Good nutrition enhances healing and improves resistance towards infection. Okay. It deficiency leads to nutritional deficiency diseases, malnutrition, blindness, etc., etc., and also malnutrition and overnutrition cause critical damage, okay, diseases, and that increases the rate of mortality. Okay. Now, that inadequacy in the food system restrict access to healthy and affordable diets. In fact, in many countries, like our India also, that we are mainly our existing agricultural systems, we are going mostly on the cereal crop production, etc. Even the fresh food is often less accessible to the masses. Many processed food do not meet the international requirement of salt, etc. And ultra processed foods, they are cheap, but they are intentionally marketed, but they do not have good nutritional quality. Okay. So for proper food and nutrition security, that food sufficient in quantity and quality, okay, physical, social, and emotional access to it, supported by adequate sanitation, health services, and care. These will offer a good, allowing for a healthy and active life. Okay. Then for achieving food and nutrition security, for nutrition secure future, obviously we have to work on three fronts mainly: that increase the agricultural production, okay, then you reduce malnutrition, and also enable structural transformation to economic power of the people. Okay, so from food technology perspective, I will take that there are two approaches, that is reducing the post-harvest and supply chain losses so that we can increase the availability of the food, and then take nutrition intervention programs, okay, to particularly increase the micronutrient content in the food. So supply chain of a produce, you see that plant processing infrastructure in upstream, as well as efficient processing, storage, and distribution in downstream become the good strategies to reduce supply chain losses. Okay. For the nutrition intervention programs, there are three methods: biofortification, food fortification, and supplementation. Biofortification, it is done in the field, at the field level. Undoubtedly, it is a good approach, but it is a lengthy process. It takes long time. The supplementation can be done at the household level, but the food fortification, okay, that is considered to be the most efficient and cost-effective nutrition intervention methods, where with the involvement of technology, it can be done at the industry level. Okay. In India, that is the food fortification of the staples has been taken, a big program, and here the wheat flour, rice, salt, oil, and milk, all these five commodities, they are being fortified with the micronutrients. So wheat flour and rice, they are fortified with iron, folic acid, and B12, and salt and oil and milk with iodine, iron, vitamin A, and vitamin D. Okay, so in all those methods, that is the mixing in the wheat flour, it is micronutrients are mixed with the wheat while it is milled into the flour. But in other cases, it is dosing of the premix. But in case of rice, really it is a challenging task. So my group at IIT Kharagpur, has done substantive work on the rice fortification. So if time permits, I will just briefly. So there are three methods for rice fortification: the dusting and coating. These dusting and coating, in both the processes, the micronutrient premix is just applied on the surface. So the drawback of these two methods is that during the washing of rice, cooking, most of the micronutrients are leached out. So the extrusion is considered to be the best method for rice fortification, because the micronutrient stability and cost effectiveness, though here we just infuse the micronutrient inside the rice. So during cooking, etc., it is not strong. So this is basically that extrusion. A extruder is a machine. It is a thermomechanical process in which heat transfer, mass transfer, pressure changes, shear rates, all these are combined to produce effects such as mixing, cooking, melting, forming, etc., in a single machine. So in the single machine, we are doing, it is a extruder. So there are different sections like feeding zone, transition zone, and metering zone. So the material rice flour, which is in the form of a flour in the powder, of course, it is conditioned when it is passed fed through this system, and when it comes at the die head, at the end of the machine, it becomes almost a viscoelastic melt. And then we provide a suitable die here, a suitable cutter, and then the material is, when it comes out of the extruder, it takes the shape of the die. That's what here. So we have designed a rice shaped die. Okay, and we are giving. So this is basically, you have to, I will not go into those details of engineering discussion, but obviously depending upon the what type of product you want, you have to manage the conditions here. System parameter, machine parameters, material conditions, etc., has to be properly managed to get the desired conditions desired. So it is a typical examples of application of chemistry and engineering, interface of chemistry and engineering. Okay, so this is our process, that is, we are taking rice flour and vitamin and mineral premix, mixing and conditioning. Finally, we are passing through that extruder. So these are the three in India. Normally, there are three rice varieties: long, medium, and small. So we have developed a dye for all those. These are the pictures of the rice which is prepared from this. These are the micronutrient premix, etc. Okay. Then, as an engineer, as a technologist, we also try to see that when we are establishing a facility, if in the same facility multi-products can be, so that becomes economically viable technology and industry. So in the same, what we did, another point was that is this fortified rice noodles, because in India, this fortified rice kernel, basically fortified rice, is given to the child feeding, ICDS programs, etc. So we thought that yes, children may like to eat noodle more than the rice. So same machine, same, only just simply we have changed the dye, replaced the dye. So the earlier, which we are giving rice shape, we gave the noodle shape. But obviously, because the cooking characteristics, product characteristics of rice and noodle are same, different, so accordingly, we have to little bit manage the engineering properties, system parameter, machine parameter, etc. But finally, we have got this noodle. It is having the same micronutrient, and it takes cooking time about 3 to 4 minutes. So it is cooking. Also, in the same process, what we did in the same machinery, here the rice dye is there, but we have little bit for diabetic people. So we have gone for a low glycemic rice, where we pick different millets, broken rice, and using linear programming formulation, we have prepared a proper blend, which finally after processing, we get a multi-grain flour, which has a low GI, less than 55. And then this flour is converted into rice. So we get a starch resistant rice, and which can be eaten by diabetic persons. So it is low GI rice. So these are another unique process that is same in the same machinery. We have now replaced that rice dye or noodle dye with a pulse dye. In India, you know that pulses, which we tell in Hindi, dal. We eat, cook these pulses, okay, and eat. It is a major source of protein. But none of the single pulse, whether it is a tur dal or it is pigeon pea or any other gram, Bengal gram, etc., none of them is balanced in essential amino acid. So what we have done, that is engineering application here, is that is we are taking the broken of various dal meals, mixing them in proper proportion, okay, so that it becomes a essential amino acid balanced dal. So we are converting them into the dal blend into the fine powder, and no additives is added here. This dal blend itself here, by having appropriate combination of the different pulses, we are getting essential. So 100 gram of this dal, this is the cooked dal, nutri dal, which we had made from the extrusion, using the extrusion technology. So it is giving the same amount of essential amino acid which you get from 100 grams of egg. So that is a nutrition, and all these technologies are patented technologies, and this is so this gives you an overview of the complete process. That is, when we go for the engineering, there is a, oh, sorry, yes, so there's some hopper, the material is being fed here, it is coming where some water etc. is added and material is conditioned, then it is automatically fed to the extruder. From extruder coming, then whatever moisture we have added here, that moisture need to be taken out, okay, so we are drying it, and finally it is packaged. So in the same setup, we are getting 4 products: fortified rice kernel, low GI rice, fortified rice noodle, and Nutri-Dal. So these are all Indian traditional foods, and these are like by this, some of this technology also we have transferred to the industry. Okay. This has been the products has been the Honorable Vice President of India, and there was that award ceremony when our scholars working on these projects. Well, so he was appreciating our rice. That's fortified rice. So these are the thing. This is the picture of the pilot plant. That is, this is the pilot plant we have established in our institute for all this, and this is all indigenously designed and fabricated and developed. Our scholars, they have designed the machinery, and then we got a fabricator, local fabricator who fabricated, and we have established. This is the 100 kg FRK per day we are producing here. Okay. So this, what is the takeaway finally? That enhanced combination of intervention strategies such as dietary diversification with more focus on greens, fortification of staples with essential micronutrients, and food technology innovations and novel processing should be employed to achieve the nutrition and health security. Okay, so this is finally, that is the permit, that is the ILSI India. Okay, that is, it is the office headquartered in Delhi, looks after South Asia region. ILSI India has been the leader in fortification programs for foods in India. It has a rich scientific portfolio. Currently, there are 8 studies. Systematic reviews have been sponsored on impact of nutrition and health. It is paying attention to developments in new frontiers of science and technology through expert committees and task forces, etc. And I have also, that is, got the privilege. I am a member of board of trustee of ILSI India. Okay, so these are some of my works, that is the books which has come out from my laboratory for scholarship. And if someone wants a little more detail of my work and what my team did, this is the website of my laboratory. So you can visit. So with this, I once again thank the organizers for giving me this opportunity. I thank you all for your patience hearing. Thank you. Namaskar. Jai Hind.